It's an e-bike workshop kind of day. So Steve's here today from Twizy Stuff channel. A few of you have been over to check out his builds he's doing at the moment of this orange full suspension bike. So go check out his channel if you want to see more about what's been going on. But I thought I'd it's going to be a bit of a mad one today because we've got stuff I want to tell you about with the 5000S. Obviously we're going to be doing some work on Steve's bike at the moment. Steve's got the, he's managed to get the wheel on there. He's got new rear suspension. He's done lots of other stuff to the bike itself, like sort out a single speed front sprocket on there, which is really good. So this is a 9-speed. This is an MTX 39 wheel with a 1500 watt motor. And what we're actually going to be doing is hooking this up to a phase runner controller. We've got where's the phase runner controller? That's in the other room, innit? We'll show you that in a minute. But basically, this is where we're kind of at the moment. Wheels in. Battery is a problem because it doesn't fit in this frame. So like most of you will know, if you've got a full suspension bike, the chances of having a battery that fits inside the frame is going to be probably next to zero. It's very difficult. Some people mount the frames at the top, some people do sort of weird kind of wooden box type things, but we're going to be doing, well, Steve's worked out a completely custom kind of battery setup, which doesn't involve building a battery, but it basically involves modding a 52 volt battery. So this is a Kirby bike 52 volt battery with no case on it. So we've basically just taken the case off completely. But we've got some wiring to do with this battery to effectively, get this to fit on the frame in a sort of custom bracket. Today, we're not really going to be doing, the kind of intricacies of making it look fantastic. We're just going to be doing like a wiring and test run job, because Steve's got a metal mount being fabricated, which he'll show you on his channel, but we'll feature it again. So today we're just going to try and get a battery on here so that we can actually kind of give this bike a test run, set the phase runner controller up, and all the exciting bits. Basically try and get something on the road because it's a beautiful day outside and we want to kind of have a little rip anyway. Neil's coming over later as well from NJ Tech channel, so it's going to be a pretty good day again of like technical stuff with the bikes and just figuring stuff out. Just taking a pair of pliers to the battery case, get it in there. So that's the bottom of the battery case, isn't it? So what we're trying to do, we're going to try and take out these connectors. Well, I don't advise doing this, guys, to a brand new battery.
We're in your warranty, guaranteed.
100%. But sometimes there's just no other way if you want to sort of do a build where you want to make something a bit more custom, or just try and get it to fit inside the damn frame, which is just a problem with a lot of these bikes.
No turning back now, we're fully committed.
Right, whilst he's doing that, I want to show you something with this bike. So this is the 5000S bike. Obviously, this one's road registered. You've seen this on the other videos. Don't need to explain it if you know. If you don't, go and check out all the other videos. Plenty on this one. This has been sat actually in the shed or the workshop for, I don't know, probably a few weeks now. So it was used and then it was kind of just sat there. So not the ideal thing. Really, your batteries should be kind of partially charged if you're going to store the bike for a little while. About 3.8 volts a cell. So you're looking at probably like 70%. So I've set up the charger for this bike and it's actually been charging for the last couple of hours. It's been doing like a 8 amp charge. So I can do that because I've got the recharger there that can kick out about 1500 watts. Super high powered charger. I've also got a tablet here which is connected to the BMS of the battery. So you can actually see exactly what's going on with every single cell in the actual battery pack. So if you look at this, you'll be able to see, if I get into the darker area, you can see what's going on here. You can see each battery, each series bank of these cells is all is showing the voltage. So most of them look okay. They're all at about 4.1 something. And got one cell 19 looks a bit lower, but we're talking down to a couple of decimal places. And at the moment on this one, you can see it's balancing the cells. So effectively it's trying to discharge all of them probably down to the lowest value, which I can't see what is, probably that 4.08 one. So that's good. It's going to get all the cells balanced out and straightened. So this is the main screen. This app is called VBMS app. It's by Tony Vortex. He's another great e-bike channel. Go check him out and buy the app because it supports him as well. A lot of work's gone into this. You can see all the information of a battery when you're using this specific BMS, and the BMSs are available from our store as well. So if you're into big batteries and kind of high powered stuff, those BMSs are really good. But yeah, aside from that, I don't usually do this every time. I don't usually check all the cell voltages all the time. Just once in a while, just whip out the tablet and just, you know, check that the battery's looking okay. This is really good because it's the only way that you can actually really see what's going on with a BMS in a battery, because otherwise you're just going blind. All you've got is your main output leads. And if it gets to a point where the battery becomes dead, you've got no way of knowing what's actually going on. So these BMSs are really great for that, because they can actually sort of help you diagnose problems that might be coming, or problems when the problem's happened. Anyway, there's a few swear words coming from over here.
Sorry,
Got it out. That looks all right. That looks fine. I just need to bend that connector back a bit. That's fine. We'll put some more heat shrink over the top of that.
Right, so this is my phase runner. It's nice,
That's
isn't
your
it?
phase runner
It's a new slimline model. So I'm thinking about mounting that on the bottom tube.
Yeah.
With the battery above it. It won't even stick on there, it's trying to embarrass me.
So you've got like...
I'm thinking of having the cables come out of the battery this end and then straight into... Do they go between the battery and the phase runner? I don't even know because I've not done one.
Yeah, they do. From the battery tray to the phase runner,
Yeah,
but
so
we're
I
going
was thinking
straight.
about exiting the cables out of the battery from this end, because we've got a choice if we're wiring it. The battery's got to be here. Do we have them exiting from that end or this end?
I would say, I mean, that phase runner, that's the right way around there. The battery connector is actually on the right hand side. Yeah,
that end, isn't
that's
it?
Yeah.
So yeah, I'm thinking about having short custom wiring that's not, you know, bunched up.
I think so.
Yeah,
It makes more sense. So we've got lots of wire and stuff like that. Steve's been on a bit of an Amazon binge and bought all the bits. I've got a lot of this stuff anyway, but some of this sort of small gauge wire you can never have enough of. And we've got the silicon wire as well.
The most important tool.
Oh yeah, those things.
Zip ties.
Steve's.
You can build anything with zip ties.
You can. These things are great.
These are awesome, aren't they? They're so strong.
Really good. I've been using these on a Vapor as well to hold the battery, the non-standard battery on there as well. They're just great. Look at the size of them.
We'll be using these today anyway, because we haven't got the bracket for the mountain bike yet for the battery, so we'll be zip tying this to death.
Yeah.
To get this up and
get something up and running. Yeah. So yeah, we've got the silicon wire, which the silicon stuff's just great because the sleeve doesn't melt. You know, this is not really a revelation, but it is really useful to know when you're ordering cable to get the silicon stuff, because as soon as you start soldering, you'll just see your plastic flipping wire just disappear as you're doing it. So that's good. Watch your finger. So the battery itself looks like a bit of a mess, but that's just because obviously the casing's been taken off. We need to do a few things to this. The first thing is we need to extend some balancing wires, which Steve's actually taken off. So that's these two here. Because the reason why we need to extend them is because he's moved the BMS over to the side so that it fits his design better. Normally the BMS is on the top of the battery, and he's moved it around the side, so we just need to extend those. So when you do disconnect these, you've got to watch this, because what will happen is the BMS will become inactive, because it will say, well, basically one cell's just disappeared, so I'm going to turn off. So make sure, you know, when you do that, you're aware that, you know, no voltage or whatever is going to be present, probably at the output terminals of the battery. The output terminals are here. He's labelled those and stuck little chock blocks on them. We're not going to be using chock blocks because they can't really carry enough current, but we'll probably use XT60s to just connect those up to either directly to the phase runner or make an extension lead for that. Other thing that Steve noticed was something had come out of one of the sides of the battery, and that is the little temperature sensor. That's what that is. It's a little thermocouple, and because Steve thought it was just a sort of wire hanging out there, he's put it in this chock block. Naughty, but hopefully this will still be all right if that little screw hasn't been tightened up too much. It might have just gone onto the wire part of it anyway. We need to tuck that back in somewhere. Normally, some of these batteries, you know, do have multiple temperature sensors across the whole pack, but you've got to have a BMS that supports that. So, you know, you're into sort of different BMSs with that, but should be all right. Neil's here, and he's also brought his bike as well, which he's building. So it's another full sus conversion with a hub motor and phase runner. Here he is, 2 bikes. Oh my God, how did you fit 2 bikes in there?
Hardest. I don't know quite how I did it, but yeah.
So this is Neil's project, which is, as I say, is the same as kind of what Steve's doing in principle, just trying to fit, you know, a hub motor set up in a mid-drive not a mid-drive, in a full suspension. So the problem you got, again, even though this triangle looks pretty big, it's the battery still won't fit. So we've still got to do some job. That's his other conversion, which you would have seen in the other videos. But yeah, so lots to do.
I just went over the camera and I made it.
We're all hands on deck at the minute, trying to sort this battery out. So So I've just started to extend this balancing cable here, just soldered directly onto the tab, and I've got the silicon cable over here, which I'm going to connect to his chock block over this side. So I need to remove that and just do a little join from there to there, and we should be good. I've got one more to do after that. Then there's a couple of other bits, including we need to put an XT60 connector on these two, and we need to change this fuse over because these fuses are a little bit low. You can squeeze a little bit more current out of these batteries, but you've got to be careful. And of course, if you do this with this battery, then the warranty will be gone.
Right, last few videos that both myself and Steve have been in, there's no ignoring in the comments that there's been plenty of times where people have said, get a lid, why aren't you wearing a helmet? The one that really hurt was, why waste a good helmet? And that's the one that got me, whoever put that comment in. So, we now have a lid, a nice strong cast. Yeah. We have gloves, we have safety glasses. You're absolutely right, guys. Andy's moaned at me a lot, so I can't blame him. But yeah, you're absolutely right, especially when we're mucking around on these high power e-bikes. Essential piece of equipment. So I did listen and we're ready to go. Okay, so a good little tip. There's lots of ways to do wire to wire joining. But the last thing you want to do is create a point that might be brittle or break or have a bad solder joint on it. The one that I tend to suggest you never really do is the wire to wire join, where you see people just put the two ends of the wire together like that.
Like what I've just done.
The strongest join that you can get is actually to open the two ends up like opening brush heads up, push them together, and once they interlock, you give them a little twist. This is beneficial for two reasons. When you flow solder in, that joint will become so strong that if you were to pull the cable, it will break somewhere else. That will no longer be, you won't be able to break
even
that.
stronger
It's
than the cable
even
itself.
stronger. So you don't have any points, especially if you lump two bits of wire together and join them like this. Where the join is, if you don't get enough solder, you could create a point of electrical resistance as well. So this way, make sure that it keeps the wire at the resistance it's meant to be at. It's strong, and it also means the wire diameter doesn't change. The diameter of the wire doesn't change, provided you don't put too much solder in. So you end up with a much better, stronger join, and a wire that you can still wrap. It won't actually become brittle and rubbish. So that's a really nice method. And the other thing as well, you'll notice I don't need a third hand here, because those two are holding themselves together, so that I can now solder this, drop the solder in with my two existing hands, and not have to worry.
It's really good actually to do this with. See, I tend to do this with the bigger wires. So like if you're trying to do phase wires or something like that, that's the way to do it. Like big thick wires, just push them into each other and then
and you're done. And now you've got a really strong, solid bond that isn't going to go anywhere. And when you put some heat shrink over that, the wire diameter hasn't changed. So it's a good, nice little useful tip for anyone who's trying to do some soldering.
Thanks, Neil. I'll just redo mine now. So what I was saying before about the little thermistor, Steve had shoved a chock block on the end, which, fair enough. Didn't know what it was. And you can see on there, I don't think you can see that, it's actually gone through the thermistor, or through the wires at least. So I'm guessing this is probably shot, this one, so we're going to have to get a new one off another battery. I've actually just managed to separate the wires apart because I didn't want to cut it with something metal so that it effectively basically created a short, even though it probably is shorted anyway. But we'll do that and we'll fix it somehow. So I've extended these two connections, that was all there was. Now I've basically just removed this little fuse holder, and I'm going to put in the daddy fuse, which is the 50 amp one. Again, probably a little bit too much for this battery, but we want to give ourselves the headroom to be able to run some decent continuous current. So what I'm going to do with this, because I haven't got a fuse holder, I'm going to solder directly onto the fuse, No problem with doing that because this fuse will hopefully never blow because we're going to be nowhere near that on the phase runner settings anyway. That's the charge port there, need to add that on there. What's the dilemma?
Right, well I mean it's the same kind of thing with whenever it comes to putting these batteries in full, especially in full suspension frames, it's clearances, just trying to make sure we can get the phase runner in but also get the be able to get the plugs in and out down at the bottom here and still clear the battery. So yeah, we're just jostling for space, trying to get everything as much clearance as it can get, but you know it's
He's looking for the help.
It's tight, but then we've also got to make sure we don't have problems here with the full travel of the suspension. But we still need to get the cables out the back, so everything affects everything else. So
yeah,
this tight. May need to go somewhere else. I don't know. We'll see. We'll just have to keep playing.
So guys, we've got a little bit of an issue. So, but most of this battery's done now. I've got the XT60 connector on here. We've done the battery switch, got a 50 amp fuse, the BMS has been located in a better place, and charge lead is actually connected as well. Got a charge lead on there as well, or charge socket. When I connect the charger, my satiator charger actually just goes off into, basically it's showing like an open circuit. So if we connect this onto here,
Heat shrinking down,
right,
nice good solid.
there you go. So you can actually see here that it's saying charge complete. It's going right away off into 60 volts, which shouldn't happen. So I'm going to test the fuse. That fuse is okay. I thought it would be because this charger has immediately just gone into saying connect battery. So I'm thinking we've got a problem with where the BMS has basically just disabled charging. So what I'm going to try and do, the reason I think that this has happened is because Steve's actually disconnected some balance wires, and I think that would then just send the BMS into a bit of a meltdown, basically saying, well, I've lost a couple of cells and what am I going to do now? Probably just turn off. So I think that's what's happened, and to try and get around that, I'm going to basically try and disconnect all of the cells from the pack, and then just plug that back in. So we need to get rid of this sort of messy gloop around there. That is actually a good idea because that stops the balancing wires coming out whilst you're riding along on bumpy roads and stuff. But we need to get that off so that we can turn the BMS off effectively, and hopefully we can solve the problem, because we want to get this charged up a bit so we can have a bit of a go. So we're just going to try and free up a bit of this gunk here, and then we should be able to get that out. There you go. Basically the BMS is connected on the negative wire here, and this doesn't go anywhere, that just goes to this plug. So the only way this BMS can be powered is if it's getting a positive from one of these balancing connectors, and that's how most BMSs are powered. They're powered by the final positive, which would be the full voltage of the pack. So by taking this out, you're turning the BMS off completely and hopefully resetting it. So let's just try and plug this back in, and with a bit of luck we should be able to get this to work. So let's turn on the charger. Still not solved it.
Could it be the temperature sensor? That it needs to have temperature sensor to function properly?
Could be. So Neil's been working on the connections for the phase runner, which I'm still looking at. That is spot on. Whoa, nice. So we've got our phase wire connection and our hall connection all running neatly down to the back.
Yeah, that's it. All at the right lengths as well. So our phase runner is going to go here, down in this space. Battery above.
Nice.
So yeah, we'll get that all nice and close, so it'll look nice and neat.
Good. And I'm at the moment doing, as well as eating peanuts, I'm just connecting the connector, because with these phase runners you have to actually connect these two wires on the throttle harness to actually turn it on and off. So they come detached as standard, because what the idea is, you use this with a cycle analyst which plugs into that one, I think. I think that's the one. And that will actually fire the controller up. But if you get one of these and you try and power it up, you know, don't think it's broken, because you've actually got to read the manual to find out that you need to then connect these two wires. So that's what I'm doing now. Then we can get this on. The throttle that comes with the Kirby bike kit actually fits onto the phase runner, so it's got that standard connector and it works straight up. So if you are going to swap one of these out with a normal controller, then that will work straight away. Anything to add?
I will actually say, you just knew, didn't you? You just knew I was going to say something. I will add, although there are a lot of manuals that you often open and you think this is just a waste of time, even if you're just hunting for a wiring diagram, I will say the Grin manuals are absolutely brilliant, so do give them a read. Even if you're thinking about getting a phase runner, go on the website, download the PDF, which will include the supplement V3 update for the latest version. Have a read through it, very readable. Everything's laid out perfectly. All the dimensions are there if you want to size stuff up on your bike. Grin do a fantastic job with their manuals.
Intricate details going on.
It was had enough. He's setting fire to my bike.
Burn! So he's just extending the throttle cable. Well, no, not extending, shortening the throttle cable, because it's quite bunched up. So he's managed to get it perfect length. So the only things left to do are, I've just got to put the battery on there and sort of mount it some kind of temporary way. And where else? Oh yeah, program the speed controller as well. So got a laptop at the ready for that. So it's nearly done, nearly done. We're still all right. It's still light outside. Still got some evening to get out. And he's just basically strapped the battery on just for a test. And Neil is now getting the controller in the right place so he can connect the program lead, and then he can run phase runner. Sweet to get it sorted, get it programmed.
Turn it on.
All right, it's all connected up. Turn it on. Yeah, got a red light on the phase runner.
Yep.
Yeah.
Solid red.
So you've got a program ready for this already, have you? Are you just going to use your one, or going to calibrate it, I suppose? That'll program the controller to the motor and all the other settings you need to set up. Like for your battery, you need to set up voltage cut-offs and probably a bit of throttle calibration in there as well. So it's like the complete program that's going to run. Lift up the back wheel.
Ready?
Yeah,
Off the ground, hold it tight.
Here we
Let's
go.
go.
Launch static test. Best guess the current kVA motor. Content right. We're going to pretend we don't know that. Launch static test.
It should do it.
So we'll do that 3 times. And now keep holding it. We're going to hit next. Here comes the spin. Let's see if it spins the right way.
Watch your legs, mate, because they're the pedals. Oh.
Wow.
That is the
I've
correct.
got some torque in that.
Yeah, a bit of
Keep
a
it
bump.
there. It's going to keep going for a little bit.
It's going the right way.
Yep. Didn't need to reverse it. If that ever does have a problem, you've got a checkbox here if it's spinning the wrong way, and it will correct it in software.
Yeah.
And there you
the
go.
holes.
So,
Should I put it down a sec?
but yeah, you can drop it now. There we go, and that's given us our KV result, 11 points, so it's nearly 12. That's about right compared to all the others, so it's actually worked that out. Yeah, that's it. And then if you lift and spin this, we'll see that in the dashboard, won't we? We'll just go
Or
next.
shall I do the throttle?
We've finished. Yeah, if you touch the throttle.
Yeah, I know.
If we go to the dashboard, in the dashboard there you can see all the different halls as the motor spins. Just lift the wheel off a minute. You can see it going between the green,
Yeah, you can see it
yellow
going
and
through.
blue, different 3 sets of halls. So now, if we go back to the basic setup,
This is where this software.
this is where we now need to mess around with how we want things set up. So, wheel diameter 26 inch, this is a 26 inch wheel, vehicle maximum speed, are you alright with 99 kilometers per hour? Does that work for you?
Should be okay.
Maximum reverse speed, we haven't got reverse hooked up, but you could actually do that, right? If you want to put a reverse button in there.
Could be the next video.
You could do that.
9 kilometers in reverse.
Yeah, hook up a reversing beeper.
I was thinking of sticking one of these controllers on the quad bike, so
That would be useful for that.
yeah, that'd be really good for that,
That'd be
wouldn't it?
perfect for the quad
Yeah.
bike, having some power. And you can actually set the maximum speed of reverse, obviously, because you wouldn't want a full power and or would you?
Well, maybe.
I don't know. Maybe you would want full speed reverse. There is actually a virtual electronic freewheel, which is a nice way to actually offset the resistance of the wheel of the magnets when you're not putting power through it. Obviously, there's some resistance from the magnets against the stator.
That sounds cool.
Yeah, so you can actually put in up to about 5 amps of current, and then you can test that and see how long the wheel takes to slow down once you let off the throttle. And that's a way of kind of making the wheel feel passive. But then obviously by doing that, I wouldn't have thought you can then regen brake at the same time. But when it senses the resistance, so when you do actually physically brake, then it will sense the load and cut off, and you'll actually hear it do that. But we won't worry about that for now. We'll just put some power in and yeah, see what we do. It's, in terms of the max field weakening current, we will tend to run about 30 amps of
About
field
30,
weakening
yeah.
is about right for this, and yeah, you'll notice that.
Don't know what that means, but it sounds like speeds to me.
That's what you want.
On speed.
Maximum speed possible.
So 30
Check
amps
all speed buttons now.
Yeah, exactly.
Any
yeah.
checkbox.
Yeah.
Haven't even tested this bike to see whether it's going to like be safe or anything. The brakes need bleeding, but just give me maximum speed, I'll be fine. Doesn't matter if the wheel falls off.
And then we've got the 50 amp fuse in here now anyway. So I think if we set it for 2500 watts, that's probably,
2500.
yeah, I think that's a starting point.
Safe.
Yeah.
Safe.
That's what the video's title is, 2500, so yeah.
So
sounds
yeah,
good to me.
we'll go with that for now.
What was it on before?
250.
That gives you
Really?
that gives you a 50
No,
amp.
50.
It's about a 50 amp current, isn't it? But it
Yeah.
probably rarely hit that because yeah, you know you're not going to be accelerating hard from a start all the time.
Yeah, and you're right at the edge of what that battery will be able to deliver current wise as well. So 50 amps, somewhere between 25 and 3000 watts, you're not going to see a huge difference because there is a limitation to that battery in those cells.
Yeah.
But it's still hilarious fun.
So this is going to be running at about 2500 watts now.
Yeah.
Yeah.
Enough.
Yeah. Well, I've not ridden one yet because I was going to go with Nils the other
Yeah.
day, but I didn't have time to. So
Your last one was 500, so
yeah.
it
I
should
think
be.
it was running about 800, possibly. I think you said. But,
Yeah, it was. It was about 800 or so, something like that.
Yeah.
But,
The other thing we'll do is adjust the torque ramp up as well.
So I would like it punchy off the line if possible.
yeah,
Yeah.
that's what I think it's that, isn't it?
Yeah, we'll try it, see how it feels at 20 milliseconds. So we don't just dump tons into the tons out of the battery at once. So see how that feels first. Save parameters. That's it. Let's go test it.
Yeah.
Here we go. So the big moment is going to give it a test.
Should I put my crash helmet on today?
Probably.
Yeah.
Otherwise, we're going to get about 900 comments.
Yeah. Obviously, this is just purely Frankenbike testing methodology at the minute. That's all it is.
So obviously this we're just testing this. So this isn't a final thing. He's actually got a mount. Steve's got a mount to get back from the fabricators, which will hold that battery in, and it will make it look even more neat. But it doesn't look bad, and that's the great thing about the Phase Runner controller, because it's so small. It just slots right in any little space, and the wiring that Neil's done here is just very, very neat. So you can't really notice it apart from that sort of stuff, but that's how it is. So we're going to give it a test. Steve's going to ride it. He's got his lid on. He's ready to go. See what happens. It's going. Whoa! And he's basically gone. What does it feel like?
It feels incredible. Once it gets over like 10 mile an hour, it just pulls like a train. Absolutely insane. But I haven't gone too fast yet because the brakes are a bit sketchy at the moment, and I don't know if everything's safe or gonna fall off. But I'm gonna try and go a little bit faster this time.
What do you reckon then?
I reckon the brakes are sketchy as hell, but it's tons of fun.
Does it feel quick?
Yeah. Oh yeah, definitely. Like, it's a little bit quicker off the line than the one I had previously, but as soon as you get to like 10-15 mile an hour, it just don't stop putting.
Yeah, that's
Even
the
then,
difference.
I was doing close to 40 and it wanted to keep going.
Yeah, as Andy was no doubt just about to say, that's the flux weakening kicking in. That's the magic bit where you suddenly, once you're over a certain point with these hub motors compared to the mid drives, when you get to 12 to 15 mile an hour, suddenly the field weakening kicks in, and that's that kind of lunge that suddenly
It just pulls.
It's
It
great.
just pulls and pulls.
Yeah.
Nice, guys, nice.
I just realised that
Andy's getting his drift.
Neil's on a hardtail and I'm like bombing down all the bumps.
That's all good.
It's good though, isn't it? All these
I've already taken this down Chick Sands. I won't lie. I haven't told you that yet.
You've been down there.
I've been down Chick Sands with it.
Have you?
Yeah.
Very good, but the only thing that worries me, I used to have a radio controlled car called a Wild Willie.
Yeah.
And the motor and everything was at the back, so it flipped. It feels like that.
Ah, really?
It just feels like ends really light because of the weight on the back.
That's interesting.
But it's quite sketchy when I'm doing 40 because it feels a bit light and twitchy on the front.
Yeah.
So yeah, a bit wary of that, but
Yeah.
got 41 out of it already.
Oh, look, I was reaching for my thumb throttle then.
The thing with this, I think because it's a wireless speedo, it takes a while to pick up the speed, almost like the GPS. But yeah, it said 41 it read, so.
That's pretty cool.
And
Where's
I've
the
done it
actual
accurate to
sensor
the
then?
tie. There.
Oh, it's there.
Yeah.
And it gets
And
from
it's
the magnet.
wireless. Goodness knows how.
Ah,
Magic.
okay. Magic.
Knows the wheel size, does it? So.
Let's see where else this goes.
Yeah, it must do, mustn't it?
Yeah.
I've not bloody been over here before.
Oh, spiky things on the legs. Even power. Is there anywhere to drop in along?
Oh no, you're not.
Nah, it looks a bit.
That's no with sand at the bottom.
Yeah, no, I'm just gonna go over the bars with that one.
It's good to be back on the bike.
Oh, it's lovely.
Yeah. That's the thing. It's like I always do this. Like I want it to be perfect, but actually, you're 95% there, and it's just still fun, isn't it?
It is still fun. I mean, I've cut my legs to bits on the cable ties, holding the battery on temporarily.
Shall I pump it?
Just trying to push this caliper back, this piston back a little bit.
Look at you. You're the brake expert now.